Okay, Bismillah ar-Rahman ar-Rahim. Continue. We did this, that was the last one. Now we'll go to the next one. As I said before, usually he will give you the V or U1, or call it the way you like. I have lambda equal to, and this is U1, so that we have U1. Right away we'll find U2, which is A minus lambda I U1. What is lambda? We say what? 2. So that will be 1 minus 1 minus 1, 1 minus 1 minus 2, 0, 0, 0, times U1, which is 0, 0, 1. That will be what? Minus 1 minus 2, 0. Okay. What is U3? Will be A minus lambda I U2. And that will be 1 minus 1 minus 1, 1 minus 1 minus 2, 0, 0, 0, times U2. Yeah, be careful here. That will be what? Minus 1 plus 2, that is 1. Okay. Minus 1 plus 2, that is also 1, and 0. Okay. So x1 will be U3. Yeah. U3 e to the power 2t. And that is 110 e to the power 2t. This is okay. This is not. This is not. This is okay. This is not. Oh, okay. So 2 answers remaining. X2 U2t U3t plus U2. That will be 110t. What is U2? Plus minus 1 minus 2, 0, times E2t. That will be what? T minus 1, t minus 2, 0, E2t. Which is this one? Yeah, this one is wrong. So my answer is A, but let me find x3 to be in the safe side. U3t square over 2 plus U2t plus U1. Yeah, what was U3? 110, 110 t square over 2. U2 was minus 1 minus 2, 0 t, and U1, which was it? What? 0, 0, 1. Don't forget all of this times E. What is the number? E to t, huh? Times E to t. That give me what? T square over 2 minus t. The last thing is 0. T square over 2 minus 2t. The last thing is 0. Then 0, 0, 1, which is exactly this one. Minus, yeah. Good. As I said, this is the usual question. As I said, usually in the exams, we have this kind of questions. Okay, but he will give you B3 or UT or U3, what you call it. Or he will give you initial condition, usually 2 by 2. Initial condition, you should get the same answer. This is the written exam. Initial condition, then we have the exam, the questions from the book. Okay. Let me do this. I have minus 1, defect 2, and he gave me B3 plus. So I have V2. Oh, we'll call it U1. Let me use the same notation. So let me call it U1. So U2 will be A minus lambda I U1. What is the lambda? Minus 1. So minus 1, that will be 0, 0, 1. 0, 2 minus 4. 1 minus 1. 0, 1. Minus 3 plus 1, that will be minus 2. Times U1, which is what? It was 0, 1, 0. Okay, who cares? That will be 0. That will be 2. I need the second column. That will be 1. Now U3 will be A minus lambda I U2. And this is A minus lambda I. Yeah, let me call this U1. Yeah. 0, 2 minus 4, 0, 1, 2 times 0, 2, 1. Let us see. This one give you 1 This one 4 minus 4 0 and have 0 2 plus 2. No, this is minus 2. Yeah, sorry, this is minus 2. So this is 0. So this is U3. So it will be x3. It will be U3 e to the power minus t. And that 1 0 0 e minus t. So this is wrong. And this is wrong. Good. X2. X2 will be what? U3t plus U2 e minus t, which is equal to what? What is U3? 1 0 0 times t, U2 0 to 1. All is minus t. That will be t 2 1 is minus t. So now this is wrong, huh? I need to check. This is wrong. So still this and this are correct. Okay. X3. X3 will make it now. U3 t squared over 2 plus U2t plus U1 is minus t. Yeah. That will be what? Again. 1 0 0 t squared over 2 U2 0 to 1 0 to 1 t plus U1, which is 0 1 0. All is minus t. That give me what? T squared over 2 0 0 2t plus 1 0 t, which is this one. So these are the correct answers. So A is this is wrong. Okay. I think it's now we figure it out. It's easy to do. Just need to, no, the same thing. He gave me V3. If you want the rest. Yeah. So this is called it U1 as usual. U2 will be A minus lambda I. U1, what is lambda is 3? That will be 2, 1, 6 minus 1. 1 minus 3, that is minus 2 minus 3. 0, 1, 0 times 1, 0, 0. That can be what? 2 minus 1, 0. Yeah, I need only the first column. Okay. U3 will be what? A minus lambda I U2. And that will be 2, 1, 6 minus 1 minus 2 minus 3 0, 1, 0 times this vector. That give me what? 4 minus 1, that is 3. Okay. Minus 2 plus 2, that is 0. Minus 1. That will be U3. So it will be x1. It will be U3, E minus T, E3T, sorry. E3T, which is what? 3, 0, minus 1, E3T. So this is wrong, this is wrong. Okay, it means this is wrong, this is wrong. Okay. Now U2 will be U3T plus U2, e to the power 3T. That will be 3, 0, minus 1, T. What is U2? 2 minus 1, 0. E3T. And that give me what? 3T plus 2 minus 1 minus T. E3T. This is okay. This is okay. This one not. This one not also. So this is my correct answer. But let me find x3 to be in the safe side. Yeah, this is x3, sorry, not u. This is x1. This is x2. So x3, use 3t squared over 2 plus u2t plus u1. That will be what? What is u3? Where is it? 30 minus 1. T squared over 2. That will get here 3t. Plus u2. u2 is what? 2 minus 1, 0 times t. Plus u1, which is 1, 0, 0. A3t. That will give me 3t squared over 2 plus 2t plus 1 is 3t. 0 minus t. The last one minus t squared over 2, 0, 0. That will be x3, which is this one. Yeah, for sure, the general solution, x will be c1, x1 plus c2, x2 plus c3, x3. Yeah. Now we'll have 2 by 2, but I have initial condition, so for sure the answer should be exact. Okay. What I have, he gave me the lambda on us. Multiplicity 2. Let me check the eigenvector to check the defect is what? It should be 1. Okay. So I have 4 minus 16. Yeah, let me do it in steps. I need a minus on the I times b1. That should equal to 0. To check how many eigenvectors I have. That will be 4 minus 16. 1 minus 7 minus 3. That will be minus 4. So I have 4k1 minus 16k2 equals 0. And I have k1 minus 4k2 equals 0, which very clear that k1 equals 4k2. I have only one eigenvector, and that eigenvector will be, I let k2 equal 1. So I get k1 equal 4. So that will be 4, 1. Only one eigenvector. One eigenvector. So D will be 2 minus 1, which is 1. I have a defective eigenvalue. So now we'll try to choose u1 such that a minus lambda I square u1 equal to 0, but a minus lambda I u1 not equal to 0. This is not an eigenvector. Okay. So let me find a minus lambda I square here. It will be what? Yeah, 1. What is the eigenvalue? Is minus 3. So a minus lambda I, that will be 4 minus 16, 1 minus 4 times itself. That will give me what? 16 minus 16, 0. Minus 64 plus 64, 0. 4 minus 4, 0. Minus 16 plus 16. Yeah, so I have the 0. Next. So here we have no restriction. So let u1 equal 1, 0. Who cares? Anything will work since I have initial condition. So the C will be controlled. Okay. And this is okay, since I have a minus lambda I u1, that will be what? 4 minus 16, 1 minus 4 times 1, 0. That will give me 4 and 1, not equal to 0. And this is, we call it u2, by the way. So we did two things at the same time. So I have u2 now. So it will be x1, it will be u2. What is I? E is minus 3t. And that will be 4, 1, e minus 3t. And what is x2? u3t U2 plus U1. Yeah, I call this U1. Okay. A minus 3t. And that will be, what is U2? 4 on 1. A minus 3t plus 1, 0. A is minus 3t. And that will be, it's written, you need to write it this way, I think better. You have 4, 1 t plus 1, 0 is minus 3t. That will be 4t plus 1 t is minus 3t. Okay, general solution. X will be C1 x1 plus C2 x2. I need to find the C's. C1, what is x1? Where is it? 4, 1 a minus 3t plus C2 4t plus 1 t is minus 3t. Now we have the condition. What is it? X at 0 equal minus 2 and 1 from here. And that equal to C1 40, no, not 40. 4, 1 e to the power 0 is 1 gone plus C2. I have what? T equals 0. So I have 1t, 1, 0. That's it. That implies in 4C1 plus C2 equal minus 2. And C1 equal 1. Then C1 times 0 C2. That will be 1. Okay, plug it here. So I have C2 equal minus 6. So my solution will be what? C1 is 1. So I have 4, 1, a minus 3t minus 6, 40 plus 1, t, a minus 3t. That will give me what? I have minus 24t plus 4. I have minus 60 plus 1. And that will be my answer. Yeah, this one, a long one. I think we did it. I remember I have the same. Did we do before? 110. Oh. Okay, let me do the calculation, everything, huh? So this is the written exam. It was a written exam. 1, 1, 1, 1 minus lambda 0, 0, 0, 2 minus lambda. That give me what? I take the third column. So I'm getting 2 minus lambda. The third row, I mean the third row. Plus minus plus, this is plus 2 minus lambda times the rest. Let me do it in details. That will be 2 minus lambda times what? Lambda square minus 2 lambda plus 1 minus 1. So I can take lambda common factor. I have 2 minus lambda times lambda minus 2 equals 0. So lambda 0, 2, 2. Okay. Now for lambda equals 0, we have what? 1, 1, 1, 1, 1, 0, 0, 0, 2 times K1, K2, K3 minus 0, so it will be the same matrix. You get what? K1 plus K2 plus K3 equals 0. And you have K1 plus K2 plus K3 equals 0. And 2K3 equals 0. So from here I get K3 equals 0. And from here I'm getting K2 equal minus K1. If you plug it here, this will be correct. You get no information. So I have V1 will be, I let K1 equal 1. So I get K2 equal minus 1. That will be 1 minus 1, 0. That will be my V1. Okay, so my first solution, it will be 1 minus 1, 0, e to the power 0t, which is C. Okay, which is 1. I mean, e to the power 0t, which is 1. Now for lambda equal to, let us see what will happen. I have what? 1 minus 2 minus 1, 1, 1. I have 1. Now 1 minus 2, that give me minus 1. Yeah, 0. And the last one, 0, 0, 0. Yeah, times K1, K2, K3 equals 0, 0, 0. So we're getting what? Minus K1 plus K2 plus K3 equals 0. K1 minus K2 equals 0. And nothing. So from here, I'm getting K1 equal K2. Yeah. Is it 1 minus 2? Lambda equal 2, huh? Yeah. Just to be sure. Yes. Yes, that's correct. So I have plug it here. I have this is cancelled, huh? I plug it there. I'm getting K3 equals 0. No. Yeah, from here one. So I'm getting V2 as an eigenvector is what? I let K2. I have only one free variables. K2 equal 1. So I have 1, 1, 1, 1, 0. So I have only one eigenvector. Means I have which case? Now I have multiplicity 2. I have the first case, which we have multiplicity 2 and defect 1. The defect is 1. Okay. Yeah. So I have for lambda equal to multiplicity 2 and 1 eigenvector. One eigenvector, I cannot say it's 1 only. So D will be 2 minus 1, which is 1. Now choose U1 says that A minus lambda I U1 square is equal to 0. What is A minus lambda I square? Yeah. What is the A minus lambda I? Where is it? For lambda equal to, that will be minus 1, 1, 1, 1 minus 1, 0, 0, 0, 0 by itself. That will give me what? 1 plus 1, that will be 2. Okay. This is minus 1, minus 1, that is minus 2. Then 0, that will be 0. That's it. Yeah. Then -1 minus, that would be -2. Yeah. This is 1 minus 1, that will be 2. And the last one 0. So you have the last one will be 1, 1, 0. Is it -1? Yeah. That will be -1, sorry. Okay. So now how to choose U1? Yeah, I need to choose U1 in a way. I get 0 here. So I think I can choose U1 equal what? (102). I need to solve this. I have only one equation here, which is 2k1 minus 2k2 minus k3 equals 0. So if I let k3 0, k2 1, so yeah, if I let k2, if I take 1 0, here is 1. I need to choose u1. u1, I have 2k1 minus 2k3 minus 2k2 minus k3, or you know, I let k3 to be 2. Let k3 to be 2. Since I have k1 is what? k2 plus half k3. I let k3 to be 2 and k2 to be 0. So k1 should be 1, which is 2, 0 minus 2, which is okay. Now I can choose u1. And for sure, u1 a minus lambda I, but be sure in a minus lambda I times u1, this is not equal to 0, which is yeah, when I signed u2, I will get it actually. This is u2 a minus lambda I times u1. That will be what? -1, 1, 1, 1, minus 1, 0, 0, 0, 0. I choose this 1, 0, 2. I want to satisfy this, but anything satisfying this, it will be okay. That give me what? -1 plus 2, 1, 1, and 0, which is not equal to 0. So it's okay. So my solution, x2, x1, I mean, that will be u2. What is the lambda? 2t. And that will be 110 a2t. This is x2, sorry. Since x1 is this one. Okay. x3 will be u2t plus u1 e to the power 2t. And that 110 t plus, oops. What is the u1? I choose it 102 e2t. And that will be t plus 1 t 2, 0 plus 2, yeah, e2t. What is my general solution? X will be c1 x1 plus c2 x2 plus c3 x3. Yeah, that will be general solution. It's a written, you can do it this way. Otherwise, any choice of u1 give you another answer, unless you have initial condition, like in this one. If you have initial condition, you should get the same answer. Let me do this quickly. I have, this is, oh, he gave you, this is repeated eigenvalues. So now I have a minus lambda I square, which is A minus lambda I times itself. 7 minus 5, that will be 2, 1 minus 4. 3 minus 5, that is minus 2 by itself. We should get 0, 0 in this case. 0, 0. Minus 8 plus 8, 0. Minus 4 plus 4, 0. So choose 2, 1. Yeah, before that, sorry, before that, I need to show that we have only one eigenvector, because it's, and this is the case. Why? This is do the calculation. No, I did the eigenvector values, so I need to solve this. Where is it? 2, 1 minus 4 minus 2 times k1, k2. For sure, you will get only one free variables equal 0, 0. That implies we have 2k1 plus k2 equals 0 and minus 4k1 minus 2k2 equals 0. Same equation. So we have k2 equal minus 2k1. So my v1 will be 1 minus 2. Let k1 equal 1. I have only one eigenvector. One eigenvector. So d will be 2 minus 1. I have a defect. I already did this. So now I choose u1 such that a minus lambda I square u1 equals 0. I have no restriction here, but a minus lambda I u1 not equal to 0. So I let u1 to be 1, 0. I think it will work. Yeah, multiplied by this matrix for sure. You should get an answer. And u2 will be a minus lambda I u1. What is a minus lambda I? That will be 2, 1 minus 4 minus 2, 1, 0. 2 minus 4. Okay, the first column I need. So my x1 will be what? u2. What is the exponential? E to the power 5t. This is my x1, which is 2 minus 4 a5t. And x2 is u2t plus u1 a5t. That is what? 2 minus 4t. u1 is 1, 0. a5t. And that is 2t plus 1 minus 4t a5t. Now I need to find the constants. So I have the condition. This is my initial condition. So I have x at 0. So what is my general solution? Sorry. X will be equal c1 x1 plus c2 x2. So x at 0 to 1 minus 5. And that will be c1 x1. What x1 if I substitute the 0? It will be 2 minus 4. Okay, e to the power 0 gone plus c2 times x2. Now substitute the 0, we have 1 and 0. At t equals 0, we have 2 times 0 plus 1, this is 0. And this is 1 minus 4 times 0, this is 0. So that implies I have 2c1 plus c2 equal 2. And I have minus 4c1 equals minus 5. What nice numbers. C1 will be 5 over 4. Plug it here. C2 will be what? 2 minus 10 over 4. That is 5 over 2. Take the other side. That will be minus 5 over 2, which is minus half. Interesting. Is it? No. Okay. Let me see what will happen. So x of t, my solution, C1 is what? Strange number, 5/4 times 2 minus 4 a5t. And C2 is what? Minus half 2t plus 1 minus 4t e to the power 5t. Now what he wants x at 1. That will be what? 5/2 here, minus 5 here, e to the power 5. Yeah, t equal 1, I have what? Times minus half. That will be minus 3/2. Okay. And here I have what? T equal 1. I have 2. E5, 5. E to the power 5. So 5/2 minus 3/2, that is will be 1. Minus 5 plus 2, that's minus 3, which is the correct answer. So that e to the power 5 minus 3 e to the power 5, which is this one. Strange numbers. Okay. This one. Yeah, he didn't give me the eigenvalue, so I will do it from scratch. 2 minus lambda 4 minus 1 6 from lambda 6 minus lambda. I have lambda square minus 8 lambda plus 12 plus 4. So I have lambda square minus 8 lambda plus 16 equals 0. That implies lambda minus 4 square equal to 0. So lambda equal 4. Now for lambda equal 4, to be sure that I have only one eigenvector, 2 minus 4 is minus 2. 4 minus 1, 2 times k1, k2 equals 0, 0. So I have the same equation. Minus k1 plus 2 k2 equals 0. I'm getting k1 equal to k2. So I get k2 equal 1. I get k1 equal to, so my v1 will be 2, 1. Only one eigenvector. So d, which is the defect, will be 2 minus 1, which is 1. So this is the defective eigenvalue. So now I'll do the other way. I will find a minus lambda I square first. That will be 0, 0. We'll check it. What was this? Is minus 2, 4 minus 1, 2 times itself. That will give me what? 0, 0. 2 minus 2, 0, minus 4 plus 4, 0. So choose u1 that a minus lambda I square u1 is equal to 0, but a minus lambda I u1 not equal to 0. I have no restriction here, so just the restriction come from here. So choose, let u1 equal 1, 0. 1, 0 will work. Yeah, it will work. So that u2, actually, I will find that it's not equal to 0. That will be what? Minus 2, 4, minus 1, 2 times 1, 0. That gives me minus 2, minus 1, not equal to 0. So it will work and find u2 at the same time. So it will be my first solution, u2 e to the power, what was the lambda? 40. That will be minus 2 minus 1 a40. And x2 is u2 t plus u1 a40. And that is minus 2 minus 1 t. u1 is what? 1, 0. E to the power 40 which is what? Minus 2t plus 1 and minus t e to the power 4t. Now my general solution, x will be c1 x1 plus c2 x2. Now do the condition. X at 0 will be minus 1 and 6, and at the same time it is substitute 0, that will be c1. What is x1? Minus 2 minus 1. Okay, e to the power 0 is 1. Yeah, I need that 0. Okay, that's good. Plus c2 at 0, that will be what? This is minus 2t plus 1. That will be 1, 0. And this is will be equal minus 2c1 plus c2 and minus c1 here. So I'm getting that c1 equal minus 6. Plug it there. I have 12 c1. Okay. Yeah. Plus c2 equal to minus 1. Not 12 c1. 12. c1 is minus 6, so this is 12. Oops. 12 plus c2. So that implies c2 will be minus 13. Correct, yeah. So it will be my solution will be minus 6 x1 minus 13 x2. Now, what will be x at 1? Now, let me do it at the same time. That will be minus 6 x1 at 1. x1 at 1. That is minus 2 minus 1 e to the power 4 plus or minus 13 x2 at 1. Here is x2 at 1 minus 2 plus 1, that is minus 1. At 1, that will be also minus 1. E to the power 4. So let me do the calculation. That will be 12, 6, e to the power 4 plus 13, e to the power 4. And this equal 12 plus 13, 25. 6 plus 13, 19. E to the power 4. E to the power 4. Which is this one. Yeah, I think I'll stop here. The remaining is just questions from the book, especially the suggested problems, which I don't think, yeah, it will be the same idea, but it's a matter of calculation. So let me stop the recording. Thank you.